Okay guys, today let's talk about the acetal mechanism. This is typically an Orgo 2 topic, most commonly discussed in the chapters involving aldehydes and ketones. Now, if you follow along with my breakdown of this mechanism, I've highlighted the most important parts. So long as you know what you're allowed to start with, work with, and have a general idea of what your finished product should look like, this is nothing more than some good old-fashioned Orgo 1 arrow pushing and charge balancing. The nice part about many of these Orgo 2 mechanisms is that there is a nice neutral halfway point, which I have circled in orange in all of my notes. If you can get to this point, you're halfway there, and the next step is almost always protonating an OH group to make it a much better leaving group, specifically water, and then usually a lone pair resonating down into a double bond, ultimately kicking off that water molecule that you just formed. This is usually referred to as hydrolysis in your textbook. So with the acetal mechanism, you're allowed to start with an aldehyde or ketone. You're allowed to work with 2 molecules of alcohol, and it's done under acidic conditions. This merely means if you need a proton or perhaps a base to balance out a charge somewhere in the mechanism, these are out there to be used at your disposal. And so HA is going to represent some kind of acid. And so if that acid loses a proton, the conjugate base is represented by A with a lone pair, just for clarification. So let's kind of look at this basic mechanism breakdown on this page, and then we'll work out a couple of examples. So here's our ketone that we're allowed to start with. And the first thing we're going to do is a proton transfer from some acid. It doesn't matter what it is. And so this molecule here is, this carbon, it's already electrophilic in nature, but it's kind of like a super electrophile once you've protonated this ketone. So then you're gonna have a nucleophilic attack by some alcohol, some ROH, right? That's going to resonate this up. That's gonna take care of this charge, but it's gonna create another one. So this is where our conjugate base comes in, just for the purpose of deprotonating that alcohol and generating this nice neutral halfway point that we call a hemiacetal. Hemi is the Greek prefix for half. So you're like halfway done. The other way I like to think of it is it's half OH and half OR. An acetal ultimately is going to have 2 OR groups. So just kind of keep that in mind. Here's where I'm at. Here's where I'm trying to get to. Notice in the final answer, there is no OH group at all. So that's kind of what we want to focus on in this next step, is just getting rid of that OH group. We know OH groups make terrible leaving groups. So to make them into good leaving groups, we generally protonate them and turn them into water. And that's what we're going to do here in this step. So then you're going to have one of these lone pairs from this OR kind of resonate down or up, depending how you want to look at it. And the formation of this double bond is going to kick off this water molecule that we've just formed. So now I've got this, and it's just a matter of balancing charges out after that. You're going to have a second molecule of alcohol, nucleophilic attack at the carbonyl position, resonate this double bond up. And then here, just charge balancing, right? Because you can't leave anything with a charge on it. And that leaves us with our acetal mechanism. It looks worse than it really is. It's just arrow pushing and charge mechanisms, or charge balancing rather. And like I said, just kind of keep an idea of what you're allowed to start with, work with, and have a general idea of what you're trying to get to. And this mechanism shouldn't be as bad as it looks. Let's try a couple more examples. So here, let's start with this cyclohexane with a ketone at the top of it. And let's try to get to this acetal. I guess we should show this O right here. So I'm gonna get this, let's maybe move this up a little bit like that so we can show all the steps. And so ignore, oops. So first thing we do is we'll protonate this ketone. So we'll just show H+, because generally once you get to Orgo 2, you're allowed to just abbreviate that proton transfer like that. And, this is, we're just grabbing a proton, right? And then we get to this molecule here. OH, single lone pair, like that. Apple Pencil is being funny today. And then we're gonna have a nucleophilic attack by our alcohol. Let's use ethanol. So it's going to come here, kick up this double bond and resonate. So now I'm at this molecule here. HO, and then OETH, single lone pair, and a +1 formal charge. Can't leave anything with a charge on it, right? So let's just do minus H plus to indicate some conjugate base is going to come along and deprotonate that alcohol to make this thing our neutral halfway point. So we have HOOET, and we can circle this. Let us know we're at our hemiacetal point like that. So like we saw on the previous page, we know an acetal is going to have 2 OR groups and no alcohols or OHs whatsoever. So we're going to focus on turning this into a good leaving group, specifically water. So maybe show a proton up here, and we'll do a proton transfer in this next step. So now I've got this molecule here, OET, OHH, draw some lone pairs here, +1 formal charge. Now, one of the lone pairs from OET is going to resonate down and kick our water molecule off like that. So now I have this OET, lone pair, +1 formal charge. And we're gonna have our second molecule of alcohol. Maybe I'll show this one in green, like that. And it's going to attack the base of that carbonyl, kicks that up. Now I have this molecule here, OET, ET, bonded to O, bonded to H, +1 formal charge, lone pair, and then our final step, minus H plus, taking off that proton to give us our nice neutral finished answer, this acetal mechanism. Now, this whole thing, this mechanism, is reversible. So often on test day with Orgo 2, you may have the combination of the following: ketone to hemiacetal, hemiacetal all the way to acetal, or ketone all the way out, and that whole thing in reverse. So acetal back to hemi back to starting ketone or aldehyde, or possibly acetal all the way back to ketone or aldehyde. So keeping that in mind, let's do maybe one more example where we start with perhaps a hemiacetal, which is what we have here. Remember, hemi half, so half OH, half OR. And we want to go all the way back to our starting ketone, okay? So let's see what that would look like. So again, what I want to kind of focus on is I notice I definitely don't have an OR group in the beginning. So I'm going to focus on making that a good leaving group. And I'm going to kind of treat it like I would water as far as protonating it, giving it a +1 formal charge, which upon leaving the molecule is then neutral, which kind of makes up the definition of what we call a good leaving group. So first thing I'm going to do is I'm going to do plus H plus, and we'll show that arrow pushing so you guys know where it's going. So this lone pair reaches out and grabs that proton. So now I have this molecule here, OH, O bonded to a methyl, and an H, single lone pair, +1 formal charge, like this. And then we're going to have one of these lone pairs on this alcohol resonate down. Just going to kick off our alcohol. So now I've got this molecule here, OH, and now we're looking pretty close to our starting ketone, like that, right? And then finally, whatever our acid is, the conjugate base is going to come along, minus H plus, deprotonate this thing in the name of balancing charges out, and that's going to take us back up to our starting ketone. Not too bad, as with any of these. The more practice problems you can do, the better you'll get at these, and certainly the faster you'll become at working these, which is advantageous on test day. If you found this video helpful, but need maybe more in-depth explanation and see a lot more practice problems worked out, you can find the full-length version over at orgogoat.com. Please like, comment, and subscribe on our YouTube page to help our videos find more students like you, and tell a friend. And if you're interested in private tutoring or you want a concept explained that you don't see on our YouTube page, shoot me an email at orgogoat@yahoo.com.